Hello and welcome to this latest edition in Low Code in 30. My name is Simon Black and I'm a technology evangelist here at Mendix. In today's Low Code in 30, we're going to be covering delivering high quality apps throughout the entire application lifecycle. Over the last few months, we've covered a number of topics in these Low Code in 30 webinars. Everything from collaborative visual development through to comprehensive security. So if you weren't able to attend those particular webinars, you can always catch them on demand on our YouTube channel. Before we dive into today's topic, I want to just give you an overview as to what Mendix is. Mendix was born to help enterprises win with apps, and it's the fastest and easiest low-code platform to create mobile and web applications at scale. The way that we do this is we have an entire platform that takes everything from requirements gathering, development, deployment and operating, and at each of those stages we try to bring business and IT together so that they can collaborate around the development of that project. By doing so, it enables us to build applications 10 times faster than traditional development and use 70% fewer resources. When developing these applications, though, we need to make sure that we're still delivering the same level of quality at a quicker speed. Software quality is a top priority for many organisations. Approximately 70% of all digital projects are failing because they're not meeting the expectations or the quality levels that the business demands. These expectations are often defined in certain requirements, and usually these are split into two: functional requirements and non-functional requirements. Functional requirements dictate how well it complies and conforms to a given design. So you come up with a list of requirements like in this ring binder here. These are often defined by the business. They're given to the IT teams who then have to go and deliver it. But often this does not meet the level of quality that the business requires, because often these are changing over time. There's expectations are changing, business requirements are changing. So therefore you need to have a different process where these requirements are gathered and they're communicated together. On the non-functional side, if we start to deliver applications that are not scalable, are not performant, we often result in situations like on this picture here, where we have frustrated end users. They're not able to use our application the way that they want to. To ensure that applications are built and meet the business needs, the Mendix platform encompasses several key tools. The first one is that we have a development platform that is designed to enable business and IT collaboration at every stage of the development process. The second is that we have a requirements management tool allowing you to have one central view of all of the project's requirements and see an updated overview of the progress whilst development. And lastly, we have a central portal so that we can manage end users' ideas, issues and bugs and be able to give those feedback from those stakeholders and iterate upon our application. Having complete visibility of all those requirements is important, but you must make sure that whilst you're building those requirements, you're consistently meeting those needs and you're not breaking things in the process. This is where testing is important. The Mendix platform treats testing no different to any other development platform. We cover all types of testing. But there are three key areas I'd like to highlight today. The first one is functional testing, ensuring what we build meets the end user's expectations, and this is usually performed using our application test suite. I'll demonstrate this later in my demo. Second, we need to have a facility for unit testing, and this is done using the JUnit module and the unit testing module from our App Store. And finally, we need to have integration testing, So we need to be able to test the dependencies between our different microservices or different applications. And usually we do this using SOAP UI. When we're developing it at speed, it's important that those applications are built to be maintainable over time. The platform is designed to ensure that whatever you build is maintainable and performable, not leaving you with a technical debt over the years. We do this on several levels, but I've highlighted 3 here today. The first one is the AQM tool. The AQM tool performs static analysis of your application models and tells you how maintainable it is and where you need to make changes. This is part of my demo later, and I'll show you how we can utilize that tool to be able to improve our application's maintainability. When we're building our application, the model is consistently checking it for errors. It usually checks 10 to 20 times more consistency checks compared to traditional programming platforms. And this is so that we can ensure that when we run the application, it will run correct first time. And finally, throughout the platform, we have an AI-assisted development. This enables us to give suggestions as to best next steps based on industry standards so that we can improve the quality as we're going through our development. In order to guarantee that applications are maintainable over time, it is also important that we reuse these components. Reuse is an essential part of software development. All Mendix applications are built using model-driven development, and this ensures that we can reuse any part of the platform and any part of the app against other applications. And the way we usually reuse these module components is by uploading those into our App Store. The App Store comes in 2 flavors, a private App Store only available for your own enterprise, and a public App Store that's available to the whole community. The App Store is a component library which really accelerates that application development. And finally, in order to have true reuse, you need to be able to break up your app into a set of single microservices. So being able to orchestrate those, being able to build those, and being able to reuse those different logic in multiple apps. So for my demonstration today, I'm actually going to use a scenario that we've used in 3 previous webinars. This scenario is around an inspections app. An inspector is on a particular container ship. He might have received an alert on his mobile device that something has happened to a particular container on the ship. He needs to go and inspect it, and he needs to then see what is wrong and record some information on his mobile device. In this demonstration, we're going to showcase quickly the application. We're going to then submit a feedback, see how we can manage that feedback, and see how we can add then user tests to that particular user story. And finally, we'll then see how we can leverage the AQM tool so that we can see how well our application is in terms of maintainability. So now that we've seen how the Mendix platform addresses quality, let's take a look at 2 of those particular platforms in more detail. We're going to look at the Ats platform and the AQM platform and leverage this particular demo application. So I have the app open in my browser here, and we can, in this particular application, see a number of inspections that we need to do on a particular container ship. We can see the task for each of those inspections, and as we drill down, we can see each individual question we need to answer when we do this particular inspection. For each of the questions, we can upload photos, we can add notes, and be able to get a complete overview as to what we need to complete for this particular task. Now, when you're developing an application, often you need to capture ideas, questions and issues from your end users, your developers or testers. And to do that, Mendix has a built-in feedback mechanism. On the right hand side here, we have this feedback button When we press it, it brings us into the feedback mode. And once we're in the feedback mode, we can select anywhere on the screen that we would like our new particular feature or issue has occurred. And this will automatically take a screenshot of where the user was at the time and also identify there where they were clicking as well. We can then add a comment to this particular feedback item so that the end user, the tester and the developers know exactly what needs to be added to satisfy my particular demands. I'm not going to go through that process today, but in earlier webinars we feature this particular scenario. So all of that feedback will go into our project management portal. And this is really where we can gather those requirements, collaborate around the initial user stories, and we can also manage out our feedback as well. So all of the feedback that users submit goes into this central portal here. We can manage the open feedback, the handled, and also the accepted feedback, and we can then tie those back into individual user stories. So when we accept a feedback item, this will go into our story section and create us a new requirement which we can then start to add test cases to within our Ats platform. So we can see here we have a user story. As a user, I would like to be able to get conditional questions based on my response. So in order to make sure that we are meeting that requirement consistently as we add new features, we need to be able to add a test script for this. And to do so, we need to jump into the Ats platform. So this is a browser-based platform and allows us to see across all of our applications which test cases have passed and which have failed over the last 7 days. So this gives us a high-level overview as to the progress of our applications. So we can see here our low-code mobile experiences application. And when we drill down on this, we can see some more in-depth information about the test cases. And over the last 7 days, we can see this graph to see how we're progressing. On the test cases section here, this is really where we can see each of the test cases or the test suites that we've recorded in this particular technology. We can also see certain test data. So we can upload test data in CSV, in Excel, and this allows us to run on a bulk upload, bulk process, a number of tests in this particular script. So we might want to test on 1,000 users, for instance, and upload them and register them into the platform. We can do this via the test data scripts. And finally, we have a direct link into those stories that we showed in the development platform there. So we can add certain test cases to those new features that we've developed. So we're going to take the last test case here, the last user story here, and add a new test case. When we do so, this sidebar will come up here. And this is where we can select existing test cases or test suites and link those to individual user stories. In our case, we're going to create a new test case. We're going to give it a name of answering questions. And we can then select a number of templates. So a template is essentially a baseline of what we want this particular test case to include. So it will include a number of steps as default. And to help with this particular flow, we already created some of these as a template. So we're going to open up the particular task, we're going to open up a particular question, and then this gives us the ability to then add our additional steps. If I hit create and open, it will take that particular example test template and create those individual steps for us. So we can see here on the test steps, we can drill down on each of those and see some more in-depth information. So for each type of activity, we'll have a number of different properties here. For this one, we're clicking a button, so we need to know the widget name that we need to click. And in Mendix, every property, every container, every button contains its own unique widget name. And this allows us to identify it when we perform these scripts. We also have the test data as well, so we can mark back which particular test data we want to use for this particular test case. We can see the usages of where it's being used. And finally, we can see those stories that have been linked, so we can add multiple stories for a particular test case. Now, when we're defining these individual steps, we can either decide to record them manually, and when we do so, we're asked to select from a particular function or an action, and there's a number of default actions in here that have been built to support the Mendix platform. So things like clicking on certain buttons, selecting certain CSS elements, all can be configured and added into this app. But we also have the option to record these. So if we want to use the browser recordings tool, we can simply select record step. What this does is now sets up a recording session for us so that we can, in the browser, click on certain items and it will create those individual steps for us. So I'm going to head over to that tool now, and we can see that we have the feedback item open from before. We can close that down now and start to add certain test items. So when we click the options here, it will record that I've selected certain items. So it will record that I've selected no and then yes. It will record when I enter in a date, for instance, and also record information like when I type in the condition of the container. So if I hop back over to the Ats platform, we can see here it's set the item as good. It's answered certain items as no for our first question. It's then answered no to the second question and then changed its mind to yes, for instance. On the right hand side here, you can see what the values are being set and what the assertion value should be. So the assertion value is saying what should that value be when we enter this information in. So this is a really good way of comparing and making sure that when we select a certain item, it's meeting those values that we think it should. The widget name here allows us to identify what we want to select and allows us to make sure that that gets run. When we hit save, what this will do is it create those individual steps here. So we can see these now in here. And we can drag and drop these in the browser so that we can move the order around. So we want to be able to select these answers before we actually hit the complete button. So now we've added some additional steps. We want to be able to run this and we want to be able to test it on a number of different browsers and also a number of different environments. So in our case, we're going to select our acceptance environment and we're going to run this on a Selenium hub. So under the hood, the Ats platform is creating a number of Selenium scripts. And Selenium is a way of creating automated tests in the browser or on the device. And a Selenium hub is a place where you can run those Selenium scripts. In our case, we're going to use Browser Stack. You can also use Source Labs or your own Selenium hub of your choice. And we're also going to select the browser Chrome and run it on a Windows 10 machine. When I hit run now, what this will do is it will take those scripts that we've defined in our Ats platform, send those to the browser hub Selenium stack, and will allow us to then test those in the browser. So if I go over to Browser Stack now, I can see that there is a test now starting to start up. That could have been triggered either manually or via CI/CD pipeline. The Ats platform has the ability to connect into any platform such as Jenkins, VSDS, and allow you to trigger these either on a new build, on a new commit, and run these in the browser. So you can see here, it runs each of these steps. So it starts the browser, it opens up a particular URL, it waits for the application to be ready, and then will perform each of those steps. Now, once it's complete, it will actually record that particular session for us. So we can view each of those steps in the video recording here. So we can see, for instance, first of all, it will go to the URL. It will then perform a login to the application. It will then finally open up the page that we want to use. So it's going to select the particular container. It will then answer a number of these questions, and finally it will hit the complete button. So you can see it's selected good now, and then it will close down the browser. If we go back into the Ats platform, we will see that it's passed the actual overall test, and we can also see a number of tests that have failed. If at any point the particular test fails, it will record at what step it failed, and also record an error log as to why it failed, And finally, a screenshot of at what point in that particular process it failed during the journey. And also you can see the recording embedded into the platform here. So we can run this and we can see why that particular step failed in the journey. So we've seen how we can leverage the application test suite to be able to record functional tests and ensure that the requirements that the end users build in the form of user stories are met using these particular test scripts. But obviously testing is a really important part of the platform, but in order to be able to add new features and be able to scale your application over time, you need to make sure that you are adding maintainability and that the quality of your application is overall going to be easy enough so that you can add new features and add refactoring over time. And to do that, we use the AQM tool. So this is the Application Quality Monitor. And this does static analysis of your application models. So it checks it for how well built overall you are maintaining your application, and it will give it a 5-star rating based on an ISO standard. It will check for things like volume, duplication, unit size, unit complexity, and give each of these a 5-star rating, and then give you an overall rating as to how well built your application is. You should always try to aim for a 4-star rating. This enables you to have loose coupling, it enables you to add new features over time much easier than it would be if it was a 3-star or a 2-star maintainability. On the right hand side here you can see a maintainability trend. So every day it will check your application using the Mendix model SDK. So it will connect using the SDK, pull all the information about your application model, it will convert it into a pseudocode, and then it will compare it against thousands of applications built in different technology types. So it might be in Python, it might be in Ruby, it might be in PHP, and it will give you an overall rating based on those thousands of applications. And we can see over time how we're improving in those individual components, whether it be maintainability, volume, duplication, and so on. We can see down here how we're actually improving or not improving compared to the last change we made. So we can see here we've made some improvements in terms of our duplication, but we've made some unit size decreases. So as we're going through, we consistently make and improve this application. It also gives us a good idea as to how well our developers within our organisation are developing. Are they using the best standards and best practices in terms of building and using snippets and reusable components? Or are they building a mess that's going to be difficult to maintain going forward? The Maintainability Dashboard gives us information as to the makeup of our application. So what type of technology are we using? We get more points if we're using more Mendix compared to using Java or HTML and so on. It also gives us information like a duplication, unit size, and gives these information easy to use graphs. The trend section lets us see over time and compare certain snapshots to see how well we're improving. So we compare, for instance, last year to this year and see overall, are we improving or are we getting worse? This gives us a really good idea as to overall, are we consistently making sure that our app is maintainable and the quality of it is good? The metrics table allows us to look at our application from the top down. So it allows us to see information about, for instance, from a system level, how many lines of code are we developing? And these lines of code, as I mentioned, are based on pseudocode, so it's not actual physical code. But it also gives us a good idea as to how many man-months it would take to rebuild this particular application. So it's based on all of these applications they've taken from different technologies, and they've come to a baseline as to how long it would take to rebuild it. Now, these man-months are different if you're building in Mendix because we are 10 times faster than a traditional technology. when you drill down on an application, you can see for each of the modules and sections within your application how that breaks down. So how many man months would it be for each of those modules, how many comments, how many lines of code, and how many elements you have within those. When we drill down further in each of these modules, we can see essentially the pseudocode behind each of those pages, microflows, or these entities. And this is how Mendix builds out its applications. It uses these visual models to build out your apps. And this is a visual representation here in the pseudocode of a particular microflow. So we can see it has an activity which is creating a variable, importing an XML, creating an import mapping. And what it will do is it will use this so that it can compare it against other microflows or other pages or other applications. The change snapshot section allows you to compare snapshots from today to yesterday and so on. The violations tab here allows us to see what have we been down marked on. So why are we not getting that 5-star rating, and what can we do to improve that? So here we can see we have some unit size violations. So this might be because we have too many items on a page. It could be that we have an entity with lots and lots of attributes. So that's not a good practice to do. We should always break those up. It will show us duplications. So where on certain pages or microflows we have duplications. And also it will give us violations if we have bad coupling. So if we have modules that are not loosely coupled, it will give us negative marks and allow us to then improve those over time. But it not only does Mendix models, it will also look at your CSS, your HTML, your Java and JavaScript if you've added those into the module. So here we can see we have some Java, which actually is fairly identical. There's several sections in here that we should actually look to refactor in a process. Finally, the last section I want to showcase is the dependency graphs. So the dependency graphs looks at your application as a whole and each of those modules and how those are coupled together. So you notice there's a number of lines in between these, and for each of the modules it will check whether those dependencies and those couplings between those modules are good or bad. So here we can see we've got some bad coupling because it's using certain activities, certain modules, and it's not using those in a reusable way. So that's why it's highlighted these in red, and we can then start to go in and fix those. So as mentioned, all of this information that is getting about these application models is provided by the Model SDK. And the Model SDK is something that we will feature in our next webinar, which will be about open and extensibility. And it's a powerful feature of the platform that allows you to do several things with it. It allows you to import, to export, but also do analysis of those models. So hopefully in the last 20 minutes or so of this demo, I've been able to demonstrate to you some of the capabilities that make up the Mendix software quality. And we've been able to demonstrate in particular the Ats platform and the AQM platform. So I hope you have enjoyed this low-code webinar.